Let's look at part B, the integral of this function. All right, so let's run it through the top like we would just a normal integration problem. Forget the fact that we're in a U-Substitution section for a minute, okay? All right, so what do? I look at my integral and ask myself, is it simply a power of x? No. Okay, then what do? I ask myself, can I think of what I take the derivative of to give me this integrating? The answer here is no, not without too much trouble here. So what do I move on to next? I move on to, do I have one of the formulas? Well, this almost looks like one of the formulas we had, right? It almost looks like this thing. I think we had du is what we used. A squared minus u squared like that. But it is different. It is not exactly this form because it is x. We have an extra x up here, so we would have to have like an extra u right there or something in the formula. But we don't have that, okay? So what's the only other thing I know? If I went through my list here, it's not a power of x. I can't think of what do I take the derivative right away to get the inside. And I don't see one of the formulas that I had to memorize, okay? So what's the only other thing? I next go to U-Substitution, okay? So let's pick a u value. Remember, we usually try to make u be inside. 1 minus 4x squared, but think ahead. If I take the derivative of this, what am I going to get? Negative 8x. Now, do I have a negative 8x? Well, I have an x factor, right? And a negative 8 multiplied doesn't matter because I can deal with that later on. So this looks like it's going to work. So let's take du over dx, the derivative of both sides with respect to x will give us negative 8x. If we multiply both sides by dx, we get du is equal to negative 8x dx, okay? So what I'm going to do here is I'm going to do a rewrite. I'm going to pull this x out to the side, okay? And I'm going to call this 1 over the square root of 1 minus 4x squared. And if I pull this x to the outside, that's x times dx, right? Now, I'm going to make a substitution here. I'm going to say, okay, we have 1 over the square root of, we call this part u. But now, I don't want anything else in terms of x. I want it all in terms of u. So x dx, let's look to replace. Well, let's get this x dx by itself. So let's multiply both sides by negative 1/8. So negative 1/8 du is equal to x dx. So now x dx can be replaced with negative 1/8 du. So I'm going to put negative 1/8 du right here. Now, negative 1/8 is being multiplied by the integrand. I can pull it all the way to the outside and say negative 1/8 times the integral of 1 over square root of u du. Now, this is a little bit difficult to integrate the way it's written. So let me do a rewrite and call this negative 1/8 times the integral of 1 over u to the 1/2 instead of square root of u. Now let's go ahead and bring that u to the 1/2 up top and call it u to the negative 1/2. So we're going to have negative 1/8 times the integral of u to the negative 1/2 du. All right, so we have negative 1/8 that comes down. What's the antiderivative of u to the 1/2? It is u to the 1 plus this negative 1/2, or u to the positive 1/2, divided by 1/2 plus c. So that gives us negative 1/8 times, multiplied by the reciprocal here, times 2 over 1 times u to the 1/2 plus c. Well, let's keep going with this. I get negative 2 over 8, or could I say negative 1/4 times u to the 1/2. I could write as a square root of u if I wanted to. plus c. And at the very end, I need to back substitute. Put this u back in terms of x. So I'm going to put in 1 minus 4x squared for u. So negative 1/4 times the square root of 1 minus 4x squared plus c. There we go. All right, part C. Part C. Want some more substitutions here. Let's see, part C, I'm going to have the integral of x cubed times e to the x to the fourth dx. All right, let's run it from the top. What do I mean by run it from the top? I mean, what is the first thing that we try whenever we're integrating? Is it simply power of x? No. So move on. What's the second thing? Can I think of what I take the derivative of to give me this? Maybe in this case, okay? But if I couldn't, what? I'd move on to the third thing. Does it look like a formula I'd been given, like the inverse tangent, the inverse sine, anything like that? No. So what do we move on to? What's the only other thing we know? U-substitution. So let's pick a value for u. How about x to the fourth? Let's see if this is going to work. What happens whenever I take the derivative here? Du over dx, that's what? 4x cubed, right? Do I have some form of x cubed being multiplied in here? Oh yeah, sure do. So that's probably going to work. Well, let's multiply both sides by dx. So du is equal to 4x cubed dx. And then we either multiply by 1/4 or divide by 4. And we get 1/4 du is equal to x cubed dx. All right, so let's do a rewrite here, okay? Let's call this e to the x to the fourth times x cubed dx. Now, all I did was commute these two terms around. And why did I do that? Because I want to have x cubed next to dx. So we have the integral of e to the what? X to the fourth we said was what? U? E to the u. What's x cubed dx? X cubed dx is also known as 1/4 du. So times 1/4 du. Now what do we do with this constant multiple? Bring it to the front. 1/4 times the integral of e to the u du. So that's 1/4. What's the antiderivative of e to the u? In other words, what do I take the derivative of to give me e to the u? Well, that's the easiest one to do. Isn't it e to the u plus c? Take the derivative. Check yourself. Take the derivative of this. See if you come up with that. Okay? And that, actually. What happens if I take the derivative of this? I get e to the u times 1/4. E to the u times 1/4. All right, let's back substitute. So we have 1/4 e. What is u again? U is x to the fourth. Plus c is in cow. There we go. Now let's see. How about d? D is in dog. D is in dog. We're going to have the integral of sine of 3 theta. Oh, we're using theta this time instead of x. Over 1 plus cosine of 3 theta d theta, okay? Now, you're going to see something in my notes crossed out here, okay? That's because I want to show you something. Now, this part right here, if you're taking notes along with me right now, do not write this part down right here, okay? But let's suppose I look at this and I make a substitution. Let u be equal to the numerator. Sine of 3 theta. Then I do, let's take the derivative of both sides with respect to x. I got to use the chain rule here, right? I got to say that's the cosine of 3 theta times 3, right? Or I could say du over dx is equal to 3 times the cosine of 3 theta. All right, then if we multiply both sides by dx, we get du is equal to 3 cosine of 3 theta dx, right? Now, if I were to go over here, I could say, okay, I call the numerator u, and then I have 1 plus cosine of u d theta, right? But can I replace 1 plus cosine d theta with any of this stuff right here? Actually, what? This is d theta here. So we used to write next. That's d theta. That's d theta, okay? But still, I guess I could go ahead and divide by this stuff here, and then d theta I could replace with du over 3 cosine of theta, but it still doesn't match up exactly here, okay? So what happened? Sometimes you pick the wrong u, like this, okay? Sometimes you pick the wrong u, so what do? Try something else, okay? Don't just give up because you picked the wrong u. So we try something else. Let's see, that didn't work. U is equal to the numerator. How about this? What if I let u equal to 1 plus cosine of 3 theta? Now, imagine taking a derivative of this. You're going to get what? Some form of sine 3 theta, right? Isn't that what I want? Don't I have a multiplier of 3 times sine of 3 theta? Yeah. So let's take the derivative of both sides with respect to theta. What does that give me? Negative sine of 3 theta. Go ahead and write this part down now, okay? This is right. So go ahead and write this part down. So if I take the derivative here, I got to use the chain rule, so I'm going to say times 3. Or I can say du over d theta is equal to negative 3 sine of 3 theta. In other words, just put this over here. If I multiply both sides by d theta, I get du is equal to negative 3 sine 3 theta d theta, right? All right, I'm going to do a rewrite here. I'm going to call this the integral of 1 over 1 plus cosine of 3 theta. And I'm going to put this sine next to d theta. Sine of 3 theta d theta. All right, so what do we have here? We have the integral of 1 over, what do we call 1 plus the cosine of 3 theta? Call that u, right? So 1 over u here. How about the sine of 3 theta d theta? What is that? Sine of 3 theta d theta. I need to isolate this part right here, okay? So I'm going to divide both sides by negative 3 or multiply by negative 1/3. And I get negative 1/3 du is equal to sine of 3 theta d theta. So what's the sine of 3 theta d theta? Negative 1/3 du, we just said. All right, bring your negative 1/3 to the outside. So that's negative 1/3 times the integral of 1 over u du. Now what is this? That's actually u to the negative 1, right? I have a formula for that. What is the antiderivative of this? It's the natural log of the absolute value of u plus c, right? Just like if I have 1 over x dx. Okay, bring down your negative 1/3. Now, what do I need to do here? I need to back substitute. So what was u? 1 plus cosine of 3 theta. So I'm going to say this is negative 1/3 times the natural log of the absolute value of 1 plus the cosine of 3 theta plus c, like that. However, I'm going to do this. I'm going to say, well, that's the same thing as negative 1/3 times the natural log of parentheses 1 plus cosine of 3 theta, close parenthesis, plus c instead. Now, why can't I just drop these absolute value signs and call them parentheses now? Well, think about this for a second. What is the minimum value of my cosine function? Remember my cosine function, if you graph it out, goes between 1 and -1, right? So the minimum value that cosine is going to take on is -1. The minimum value is going to be -1 plus 1 gives me 0, right? And if it's anything greater than -1 and I add 1 to it, I'm going to get a positive in here, right? So either way, I either get a 0 or a positive of my absolute value. What's the absolute value of 0 or some positive number? Itself, right? So since this is always going to be 0 or positive in this case, I don't need the absolute value anymore, and I could call it that. Oh, now we're getting serious here, right? With these type of problems. Speaking of getting serious, let's stay getting serious, okay? Next example. And this is what I labeled as less obvious substitutions in my notes, okay? Less obvious substitutions. Let's see. This example, we're going to have part A. Let's find the integral of sine of 2x in my numerator over 1 plus cosine squared of x, or cosine of x squared, I should say, dx, okay? All right, let's run from the top. First of all, is this simply a power of x? No. What's the second thing I try? Can I think of something I take the derivative of to give me this? No. What's number 3 that I try? Is it one of those formulas I had to memorize? No. So what's the fourth thing I know? What's the only other thing I know? Try U-Substitution. All right, so I'm going to let U equal to my denominator. 1 plus cosine, make that a little better, 1 plus cosine of x squared. And let's take the derivative of u with respect to x. That'll give me what? Remember, this is squared, so I got to use the chain rule. I got to say 2 times the cosine of x times the derivative of the inside. Because remember, this is really what? 1 plus cosine of x squared, right? So I said derivative of the outside at the inside times the derivative of the inside. So I get du over dx is equal to, that's a -2. And I could call this cosine times sine, or I could call it sine of x times cosine of x, right? And let's multiply both sides by dx. So du is equal to -2 sine of x times cosine of x dx. Get rid of this stuff. All right, so let's try this, okay? We're going to do a rewrite. We're going to say this is 1 over 1 plus cosine of x squared times sine of 2x dx times sine of 2x dx. Now, all I did was factor this sine out the top, okay? All right, well, let's see. This is the integral of 1 over, what did I call 1 plus cosine squared? Call that what? U times sine of 2x dx. Now, do I have sine of 2x dx right here to replace? Not really, right? What could I do? What can I do with this stuff? Well, what I'm going to do is think of it as -2 times sine of x times cosine of x dx, like that. And what does this look like? Doesn't that look like my double angle formula from trig? It's exactly my double angle formula for trig. So I could say that this inside part is going to be the sine of 2 times x dx. We can't forget about the trig identities. Now, this part, I want to get by itself, right? So I'm going to divide both sides by -1, and negative du is equal to positive sine of 2x dx. So what's sine of 2x dx? We just said that's negative du, right? Pull your negative or your -1 to the outside. So you have negative integral of 1 over u du. So negatives out front. What's the antiderivative of this? Natural log of the absolute value of u plus c, right? So that's negative natural log of the absolute value. Let's back substitute. What was u? 1 plus cosine squared, right? 1 plus cosine squared plus c. Now let's see if we can lose the absolute value signs this time. No matter what my cosine is, I'm going to square it, right? So it's either going to be 0 or positive if I square it. 0 or positive, if I add 1 to it, is a positive number, right? So what's the absolute value of a positive number? The same as that number in here. So I could drop those absolute values and say this is negative natural log of parentheses 1 plus cosine squared plus c. And there's probably more than one way to do this problem. I'm not going to show you a bunch of different ways, but you could probably use an identity here and so forth, okay? Let's see. Let's take a look at part B here. Part B. Part B, these less obvious substitutions. Part B. All right, so for part B, I have the integral of the square root of 1 plus x squared times x to the 5th dx. All right, is that simply a power of x? Nope. Second thing I try, can I think of something to take the derivative of to give me that? Nope. Let's go on to the third thing. Is that a formula I had to memorize? Nope. Go on to the fourth thing, U-Substitution. So I'm going to say, let's let u equal to 1 plus x squared. 1 plus x squared. Now let's take the derivative of both sides of this with respect to x. We get this, right? So du will be equal to 2x dx. So over here I'm going to have the integral of, what's 1 plus x squared? 1 plus x squared we said was u, right? So we have the square root of u times, how about x to the 5th dx? Do I have an x to the 5th dx? No. In fact, if I multiply both sides by 1/2 here, I have 1/2 du is equal to x dx, right? So I have x dx to replace. But I don't have x dx here, do I? Man, that's Cosine. What do I do there? Well, let's be clever here. Yeah, I don't have x dx explicitly written here, but couldn't I do this? X to the 4th times x to the 1st dx. X to the 4th times x to the 1st is x to the 5th, right? Now I have this x dx like I have here, right? So this is going to be the integral of the square root of u times x to the 4th times, instead of x dx, I'm calling that 1/2 du, right? But wait, I have u's and x's. I still didn't get rid of that x. Well, let's do this. Let's go back here and let's solve this small equation for x, okay? Or for x squared. I'll have u minus 1 is equal to x squared, right? Well, what if I square both sides of this? I get u minus 1 squared is equal to x to the fourth, right? So what are we saying? X to the fourth is u minus 1 squared. So what can we replace this x to the fourth with? U minus 1 squared. So we have the integral of the square root of u times u minus 1 squared, we just said, for x to the fourth, times 1/2 du, but I'm going to take this 1/2 and pull it over here, okay? So this is 1/2 times the integral of, I could call that u to the 1/2 exponent instead of square root. Now let's square this out. What's u minus 1 squared? U squared minus 2u plus 1 du. Now what do? I distribute this u to the 1/2 here, and I get 1/2 times the integral of u to the 2 plus a half. What's 2 plus a half? 5/2? Minus 2u to the 1 plus 1/2, or we could say 3/2. And u to the 1/2 times 1 is u to the 1/2 du. Now I have it to a spot where I could take an antiderivative, right? Let's do so. So we have 1/2 out front. Then what do we have in the inside here? What's the antiderivative of u to the 5/2? That's u to the 5/2 plus 1, or 7/2, divided by 7/2 usually we do. But instead of divided by 7/2, let me just put times 2/7, because we're going to have to do that anyway. Now we're right here, minus 2, u to the what? 3/2 plus 1 is 5/2. Then we could say divided by 5/2, or we could say multiply by 2/5. Plus, how about u to the 1/2? Let's take an antiderivative. That's u to the 1/2 plus 1, or u to the what? 3/2 times what? 2/3 plus c. All right, let's see what this gives us. This gives us 1/2. Well, let's do this. Let's go ahead and distribute the 1/2 here, here, and here, okay? 1/2 times 7/2 is what? A 1/7 u to the 7/2. 1/2 times -2 is -1. So we get -2/5 u to the 5/2. And 1/2 times positive 2/3 gives me what? 1/3 u to the 3/2 plus c. Now what's the last step? For each one of these u's, we want to put back in terms of x. So we want to say u is 1 plus x squared. So we have 1/7 times u to the 7/2. But we said u was 1 plus x squared. Minus 2/5 times u to the 5/2. But what's u again? 1 plus x squared. Plus this 1/3 times u to the 3/2. U again is 1 plus x squared. Plus my arbitrary constant c. Whoo! Tough problem there. Learn how to do these though.